We are Ian and Laura, and our project is activated carbon from agave bagasse. In Mexico, there is plenty generation of agro-industrial waste, and the tequila production is very important in our country. It produces tons of agave bagasse annually. In the other hand, the activated carbon is used as an adsorbent, with multiple applications in the industry, such as purification of air and water and adsorbent of pollutants from both gas and liquid phases. The 40% weight of waste in tequila production corresponds to bagasse. For example, in 2014, 240,000 tons of bagasse were produced, but only 59% had a secondary treatment. The idea is to use that waste, which is cheap, to produce a very important project for the industry. In this graph, we can see the agave required for the tequila production. It has increased in the recent years, and so the bagasse waste.
In the Mexican production of tequila and mezcal, agave bagasse was created as a consequence from the distillation process. This implied an issue because, at the time, this material was only considered waste. Consequently, they resorted to burn this waste, creating a bigger environmental problem. Later on, they started a procedure in which this waste was used in a better way. Unfortunately, it did not have a big impact on society and users to commercialize it in a big scale. As the investigators around the world were looking for a new raw material in the activated carbon production from the agricultural byproducts, this research joined with the one of giving use for the agave gas from the distillation tequila and mezcal process, and with a chemical reaction phase, they found a way in which activated carbon could be created with the industrial waste of agave gas. The first part of the process is to grind the agave gas. Afterwards, these fibers are blended with phosphoric acid in aqueous solution in a mixer, resting there 12 hours. The next step is a pyrolysis in an inert atmosphere, using argon for this purpose. The outlet is heated from 500 Celsius to 580 Celsius until the phosphoric acid is completely evaporated and separated from the mixture. This new mixture is cooled down until 25 Celsius in order to control the substances easier. Two washes are suggested in order to clean the carbon and remove any rest of phosphoric acid. First, from 1 to 3 washes with 3 distillated water, and then the second washer, with chlorhydric acid. For the PVD or the block diagram, we took information from several processes we found. If you are interested in consulting them, they are on our bibliography. And now, on the flow diagram, we focused only on one process from the ones mentioned before, and also we added the conditions we needed in order to make it work properly.
For the mass balance, we use the principle that states that everything that comes in comes out. For the energy balance, we use the heat of formation methodology, using the specific heat in order to calculate the sensible heat of every substance, the heat of formation of every compound, the heat of vaporization for the latent heat in a phase change, and we define a different reference state for each unit operation. We use the energy balance to calculate the energetic requirements of our process. For the calculations of energy and mass balance, we made the following assumptions: that the pyrolysis were achieved at 100%, the bagasse is conformed by a lignin, cellulose, hemicellulose, water, and ashes, that the ashes were solid and just heated, and the process was made at 1 atmosphere.
The average salary for a recently graduated chemical engineering is around 7,000 and 9,000 pesos. Based on this salary, on transportation, internet, and food costs, on how many hours a day, and on how many days we worked on this project throughout the semester, we calculated that we should sell this project approximately on 10,900 pesos. The hours we worked are described better on the Gantt diagram.
The cost of the agave is between 8 and 100 US dollars per ton, and we use 3.7 tons per day or per process. The energy required for the reactor is to cool it down, for the heater is to heat, and for the condenser is to cool it down too. These three are electric, so we are considering only the electricity they need to work. The table shows the prices per year, considering that the process is made once a day and that there is 254 business days in a year. If needed, the process may be modified in order to duplicate or triplicate the production. It depends on the agave gas obtained because the reactors are pretty simple to obtain and cheap. As the process only produces 105 kilograms of carbon per year, we may think that it is a small project or small dimensions, but we should take into account that the phosphoric pentoxide may be sold or reused in another process, and also the argon, water, and chlorhydric acid may be reduced in this process or in another.
Here's a description about how the project was managed, about the role for each teammate, about the hours with how many hours we spent, and basically about what was the activity that each teammate do during this project throughout the semester.
In order to improve our process, we suggest to change the phosphoric acid with an activator that is less pollutant, for example, the chlorhydric acid. Also, the water used in the multiple washes may be recycled in some coolers or filtered and reused in the washes. As the coolers considered in the process are electrical, it would be a good idea either to obtain the electric energy from renewable sources or to change the electrical coolers for recirculation coolers in order to implement the past suggestion. In the heater, the regular fuels may be replaced with hydrogen combustion in order to reduce the production of carbon monoxide, carbon dioxide, and other gases produced in the pyrolysis and combustion.
By a change of pressure, the extreme increase or decrease in temperature may be reduced. Therefore, they will be using less energy in heating up these procedures, and this means less money invested. Recycling. Not only water, but other materials can be key in order to find a way to get costs lower. If they can reuse the chemical components they are using, they could be utilizing it at maximum. Maybe not everything can be used in this particular process, but of course, this is not the only processes this company work on. So, in previous processors, this can be useful. For example, the phosphorus pentoxide can be sold or used in other procedures in the same plant. These companies have to be updated on new technology coming out every day. Scientists are finding new ways in which companies can utilize wastage in a good way. For example, we are closer as they pass to get carbon dioxide useful into fuel. It will indeed be expensive to invest in these new technologies, but in the long term, it will help the company, and not only the company, but the planet. We see it as a necessary change not only for this company and for this particular process, but for companies working with chemical components throughout the world.